Well, hello everyone, and welcome to today's database lesson. This is Jacqueline Corley, and today is going to be all about one of my favorite topics in the database development industry, and that is on normalization. Not only is it one of my favorite topics, but it is also one of the most important topics that we really need to understand clearly. And so my goal for you today is to not only be able to visually see how you would restructure the database as far as normalization rules go, but also for you to really get a good understanding and grasp of the concept of normalization. Because a lot of times when we study computer science or anything with technology, we tend to be so quick, or maybe I'm the only one, but we tend to be so quick to want to be hands-on that we forget that there's a concept that we've got to understand before we're hands-on. This is definitely one of those topics you do not want to miss the concept of, because there's a lot of information, especially when we start talking about the different normal forms, that you can miss if you just jump right in to the hands-on. So what I'm going to do is I'm going to introduce each section of what we're going to talk about with the conceptual part, and then we're going to get into SQL Server to see how normalization works. So first of all, let us understand what is normalization. Here I have that it's used to improve the quality of the database structure. Normalization exists to ensure that the data is as clean as possible by avoiding redundancy and anomalies. And those two words are simply just fancy words for repeating data and incorrect data, or data that is not necessarily normal, okay? But really anomalies just mean incorrect data. Normalization rules have been created or put in place in order to accomplish this goal, and these rules exist in normal forms. So when we start thinking about what normalization is, get into your mind that the whole purpose is simply to improve the quality of the database structure by avoiding redundancy and anomalies. And the way that we do that is we do that through normalization rules that exist in normal forms. Okay, so that is what normalization is in a nutshell. Now, when we start to talk about the different normal forms, let's see what they are. The three most commonly used normal forms are first normal form, which is 1NF, second normal form, which is 2NF, and third normal form, which is 3NF. Okay, and as you go further into these normal forms, or you go down into these normal forms, the normalization rules will get more strict. And when we talk about these here in just a minute, you'll see how strict they get. The decision to expand beyond the third normal form is usually determined by the particular company for which the database operates. Majority of the time, you will not have to go past third normal form. Okay, really the idea is to just take a look at various different situations or things that need to be examined in the database and help improve those things by taking various different steps in order to do so. And that's how we utilize these normal forms. Okay, so that's normalization and normal forms in a nutshell. All right, so before we start getting into some examples, what we need to do is we need to understand the concept of dependencies. So basically, in a nutshell, what a dependency is literally what it means. Something depends on another thing. Now that may sound a little simple, but it's truly all in all what that means. Here in this picture I have here, I want to show you guys what that means in database terms. So here is the person table, and this person table has a person ID, first name, and last name. Now, what we have here is the value of person ID depends on the person entity, okay? So the idea here is that attributes depend on the entity, as we can see here in this chart. And the entity is the table itself, and the attributes are the data members or the columns inside of those tables, okay? So in this case, the entity is person, and the attributes are person ID, first name, and last name. And in just like any table, the attributes are simply every column that is located inside of those tables, okay? We just need to know that in order for an attribute to exist, it must depend on an entity. We know this from basic database systems. We cannot have a column or an attribute without a table or an entity. That's why it's so important that when you are creating a database that you do something called AERD, or entity relationship diagram, so you can actually start to see how these entities relate to one another, okay? A lot of times they're more focused on how we relate to various different tables, but here I really wanted to show you guys the importance of just how much these column items depend on the table itself. So in a nutshell, an attribute cannot exist without an entity. That is the basic concept of a dependency. And when we get more into the normal forms here in a little bit, you'll be able to see more why dependencies are so important. So let's move on to another example now that we can actually see the data itself. Okay, so let's take a look at this particular table. So here is an example of redundancy and why we want to get rid of it, and also an example of an anomaly and why we want to get rid of it. So let's say this is a database table of employees. And let's say every employee has a username, we have retrieved their name, and we also have retrieved their phone number. Well, it looks like Karen Smith has 2 different phone numbers. So the problem here, though, is that there's redundancy of data, not only in the username, but also the name, okay? While it may be true that Karen S may be tied to Karen Smith and Karen Smith may have both these phone numbers, this causes data redundancy and causes a lot of problems in your database. So what would need to happen is you would need to create another table that outlines the data that is being repeated, which is multiple phone numbers. So you would create another table that outlines all of the employees' contact information, okay? But then also too, here's another problem down here. Yes, we have a different name and a different phone number for Karen Snyder, but Karen S is still the username here, okay? So now we have a question of, is this supposed to be Karen Smith or is this supposed to be Karen Snyder, okay? Now, why would an anomaly happen like this? Because right here, having Karen Snyder and Karen Smith as 2 different names is an anomaly for the same username, which means that's not correct. This table is supposed to only have usernames tied to one person, okay? So you're probably wondering, okay, how do these types of anomalies happen? Like, they don't just happen out of nowhere. Well, what I've seen in industry is, I remember when I first went into industry and I was working with the database that I worked with, and I knew that this SQL Server database had not always existed since the company started. And so the company was actually holding this data in a different system. I don't know if it was spreadsheets, I don't know if it was Access databases, but it was not held in a relational database model. And so when a lot of the data transferred over, there was a lot of incorrect data, things had to be shifted around, and a lot of normalization had to happen. So that could be one way by the data import. Because sometimes, a lot of times when we don't know exactly the information that needs to go inside of a particular column, once it's transferred over, what tends to happen is default items tend to be set, but they may not really be the actual information. For example, I remember in one database I was working with, the date was set to the opening date of the company, which we know those records were not created on the opening day of the company. Okay, so that's one reason how data redundancy and data anomalies can happen. Another way they can happen is if the company has a web-based application that this database uses, or has a Windows desktop application that this database utilizes, and you have users who may enter the wrong information. Okay, it happens all the time with data entry, people not entering the right information. So in this particular example, it is possible that maybe Karen Snyder is a new employee, or Karen Smith, whichever one of these is a new employee, and maybe the person that entered, the new employee, through that application entered the wrong name. So that's also possible too. Okay, so not only did I want to show you what data redundancies can be and what anomalies can be, but I also wanted to show you how those can happen, because those don't just pop up. Okay, so there are plenty of ways that these can happen as well. Okay, another way that data can be incorrect is, of course, if the data gets hacked or something like that, which we'll also talk about in the next couple of lessons. But I really just wanted to show you guys where those can come from and what they actually look like. Okay, so this example here is just simply displaying which data is redundant and which data is an anomaly. Now, you're probably wondering, okay, well, it has Karen S and Karen Smith seem to be the ones repetitive. Why did you say that the phone number was, kind of the one that's repeating or has multiple values? Well, the thing that's causing these two things to repeat is this phone number, because there are two different phone number attributes for this same person. So this person is displaying twice in the database. Now, one temporary fix that can be done if you are doing a query, especially if your job is to ensure that data is normalized, and it may take a process, right? It takes a while, especially if you've got a huge database. Well, if that's your project, one temporary fix that people tend to do with queries is in their select statement, they just say select distinct. Because sometimes in your queries, this can pop up this way, okay, which is fine as long as it's not the actual table that this information pops up in. But if you don't have a database that properly connects this info, then you're going to start having data redundancy. So this redundancy here is caused by the multiple phone numbers that exist for this person. But we also have a data anomaly too, because now we're not sure if Karen Smith or Karen Snyder actually has this Karen S username. So in order to avoid things like this is why we have our first, second, and third normal forms. And let's get into those now.